This lesson we'll be looking at arcs in circles. And so what I first want you to do is just label your notes arcs. We'll also look a little bit at chords, which you already should know what that means. Okay, we're going to look at this circle right here. And I'm going to tell you how to label certain parts of it. So if you want to label an arc, and all an arc is one point to another point on the outside or right on the line of the circle. So an arc, a regular arc, is named by using the endpoints. And this P is called your central angle. And so when you're doing the angles, you want to include that P in your angle. But for example, for angle APB, if you want to find the arc or label it, all you have to do is do A and a B and a little arc over it. So that just means the arc AB. And this means the angle, the central angle, APB. And that's just a minor arc. So we're going to put up here minor arc. And a minor arc is, all a minor arc is that if it's less than um, 80 degrees, or 180 degrees, sorry. Because at 180 degrees, that's going to be a semicircle. So a minor arc, this one would be considered a minor arc because it's less than 180. But if you have a major arc, which would be the rest of that circle, so we're going from A all the way down to B, you need to include one of the points. Because if I just said AB again, you might think that one. But since it's a major arc, you're going to have to do this. You're going to go A, C, B, because it includes one of the points on that arc. So that's a major arc. The measure of a minor arc, so if you want to find the minor arc, you're going to write it like this. You're going to say, like, let's look at this one, for example, and let's say that AB is 60 degrees. So the way you would write that is you would say the measurement of arc, AB is equal to 60. And, the measurement of GEF, I'm sorry, I was using a different example. The measurement of ACB, the arc, is going to be 360, because that's how many degrees in a circle, minus 60 degrees. So that major arc is 300 degrees. Okay, let's look at our arc addition postulate. The measure of an arc formed by two adjacent arcs right next to each other is the sum of the measures of the two arcs. So all that's saying is that if you have arc AB and you have arc BC and you added those, you could find out the total arc amount. That's all you're doing there. Another thing I want to put out there is that a semicircle could be an arc if its endpoints are the diameter. So for example, you have this circle and you have a point here and a point here, and you needed to find the measurement of the arc. You're just going, this is a semicircle because it's the diameter, so it's going to be 180 degrees. Okay, let's move on to the next one. Find the measures of the blue arcs. Are the arcs congruent? So let's look. So in order for it to be congruent, you need to have congruent circles or be on the same circle and have the same degree. So this one is on the same circle and they have the same degree. So the measurement of the blue arcs, AB and DC, are 45 degrees, and yes, they are congruent because same circle, same degrees. Okay, let's look at B. We have PQ and we have RS. They're both equal. Get rid of that degree, actually, it's just 45. They are both equal to one another with their angles, and because it has the same radius, they are congruent circles, so therefore these are congruent arcs. Okay, let's do C. So looking at this one, you know that XY is 65 and ZW is 65 degree arc. Actually, yes, put the degrees. So they're both 65, however, they're not in congruent circles, so no, they are not congruent. Okay, let's look at some theorems. So theorem 10.4, in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So we have AB, we have this arc here, and we have BC. The only way they are congruent is if BC is equal to AB, and in this case it is. So those are chords. They're not the diameter or the radius. They're going from one point of a circle to the next without passing through the center. Okay, theorem 10.5. If a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So here's our diameter. It's perpendicular to a chord. So then what happens is it's going to bisect this, so that means these two are equal. And it also bisects the arc here, so those two are equal. Theorem 10.6, if one chord is a perpendicular bisector of another chord, so we have this chord and we have this chord. They aren't indicating that it went through the center, so that would not be the diameter. But according to this theorem, I'm saying it wouldn't by the picture, but according to the theorem, if you read it, it will be. So if one chord is the perpendicular bisector of another chord, so we have chord, chord, then the first chord is the diameter. So if this one is the bisector, this one is the diameter. So it's kind of saying the opposite of what we have in theorem 10.5. But if you do have a chord going across and you have a perpendicular bisector to it, you know this one must be the diameter. Okay, and let's look at the last theorem. In the same circle or in congruent circles, two chords are congruent, so we have two chords on here. If and only if they are equidistant, means same distance, from the center. So you have your chords, and what you do is you measure from the chord to here, to the center, and the other chord to the center, and then you measure those. And if it is, those two chords are congruent. So in this case, they didn't really say that, they're saying it down here. So AB is congruent to CD if EF is congruent to EG. So that's all you need to know today, and we'll work on it tomorrow.